Alright, today we're talking about expressions with integer and zero exponents. So how do we use exponents when they're either zero or they have integer exponents? So I'm going to go through a little exercise here, alright? So 3 squared is 3 times 3. Alright, 3 times 3. 3 times 3 is equal to 9. Now 4 to the first power is just 4. So the answer is 4. And 6 to the third power is 6 times 6 times 6. Now here, I want to see if you can catch the pattern. 3 to the negative 2 is 1 over 3 times 3, or 1 over 9. 4 to negative 1 power is 1 over 4. And 6 to the negative third power is 1 over 6 times 6 times 6. So see if you can see the pattern between the first rows and the second rows. Alright, we'll talk about it in just a minute. I just want to give you the last one. 3 to the 0 power is 1. 4 to the 0 power is 1. 6 to the 0 power is 1. This is how it works. Alright, we know the positive sides. So we know all of these. Alright, here you can see that if we have a negative exponent, what we do is we take the same exponent and we put it over 1 or under 1. So it's 1 over 9. It's 1 over 4. It's 1 over 6 times 6 times 6. Anything to the 0 power is equal to 1. Alright, so I want to simplify. To simplify, you want all your exponents to be positive. This is how that works. Alright, if I have p to the negative fourth, that's equal to 1 over p to the fourth. Alright, if I have m to the negative third over n to the fifth, that's 1 over m to the third n to the fifth. If I have 1 over b to the negative eighth, that would make it 1 over 1 to the b to the eighth power, which equals b to the eighth. So a negative will always bring it to the opposite side. Here you can see that this negative brought it to bottom because it's on top. This negative brings what's on bottom to the top. And so these are my answers. We want to evaluate when a equals negative 3 and b equals 5. I'm going to simplify this first. First off, we know that it's a squared and b to the 0 is just 1, which makes this equal to a squared, which equals negative 3 squared, which equals 9. Here we have 3. This b is positive, so that will stay on top. This b is negative, so that will bring it down here, which makes it equal to 3 times 5 over 5 times 5 times 5 times 5. You can see that these cancel each other out, which makes it 3 over 5 times 5 times 5. And 5 to the third power is equal to 3 to the 125. The quotient rule. So we had the product rule for exponents, so now we have the quotient rule. If m and n are real numbers and x does not equal 0, then x over m is equal to x to the m minus n, which is equal to 1 over x to the m minus n. Alright? And so let's see what this means here. Alright? So what this tells me is, since I have the same base, when I'm dividing them, I can go 8 minus 4. The numerator minus the denominator, which makes it x to the fourth power. Here I can make this equal to x to the 10 minus negative 3, which makes it x to the 13th power. And finally here I can go x to the 7 minus 3, y to the 2 minus negative 5, and z to the negative 6 minus 2, which makes it x to the 4th power, y to the 7th power, and z to the negative 8th power. Hey, let me know if you have any questions. We talked about the quotient rule today. Let me know if you have any questions. I'll be happy to answer them. Have a good evening.